Example 6. Okay, let's move on. A magazine reports that teenagers make an average of 15 minutes of outgoing call every day. Wow, 15 minutes every day. Times 30, that's 450 minutes. What is a lot of talk time, eh? You don't talk so much, man? No, right? They only WhatsApp, right? Data. Not enough data only. 2 gig not enough. Oh, use school Wi-Fi to WhatsApp, right? That's why you complain slow. Not my problem. Because you all clock up, right? Oh, okay. I digress. Denwa suspected the average is not correct and wanted to verify it. So took a sample of 8. Quite stupid, right? Go and take 8 only. So n equals to 8. So he lazy lah, not stupid lah, not lazy lah. So only 8 teenagers where n is x the amount of outgoing calls in minutes. Test Denwa suspicion with a two-tail 10% significance level test. There are a few things that you want to note. First thing you see, x is not, no, wait, cannot say this, yes. First thing, n is small. Second thing, sigma square, unknown. Follow? N is small, sigma square unknown. Then you immediately say, okay, then it must be here. That's right. See, N is small, population variance unknown. Then it must be a t-test. Clear cut. But just now I didn't mention, in order for this to be a t-distribution, because these two are variables, there is an important assumption there that x must be normally distributed. The population x must be normally distributed. Important assumption. Then you ask, what if x is not normally distributed? My answer to you, quick answer to you, is not in syllabus. Similar for this case. Follow what I'm saying? Not in syllabus. So important thing is for this to be a t-distribution, your x must be normally distributed. Your population must be normally distributed. Then you ask, in the problem, can you all read? Is there anywhere in the question that says x is normally distributed? Nowhere. Then if this question were to come out and say, panic, cannot do. Don't do, give up. Then you read further, there is this question. State any assumption made in testing Denwa suspicion. Your assumption must be x. One more time, your assumption must be x must be normally. Follow. Okay, so I'm just going to go through the problem now. Unbiased estimate of population mean is 43/4. This one just fine now. This one also just fine, okay? Can? So what's good? Since you don't know variance, you just estimate variance by unbiased estimate. So we define step 1. Step 1, define mu. Actually, I don't know why I leave this blank for you. Should just put it for you, right? Then you just copy like, never mind. For those people sleeping and wake up now, copy. At least you come here and copy something. Not many jokes to tell today. Actually, I'm not very good at telling jokes. Really. You ask my class S3 too, my tutorial class is very boring. They always fall asleep. Yeah, you know so. Goodness. Okay? So just write, just copy it. First thing, definition. Second, you look at the question, do you do a one-tail test or a two-tail test? You want to check whether mu is indeed 15 or not equals to 15. You are doing a two-tail test. And your level of significance is 3. Is step 3. Test statistic is this. Now, I think I've answered the question. When H0 is true, you need to assume that X follows a normal distribution. Otherwise, this test statistic cannot be a t-test. I'm now very quickly going to show you how we are going to calculate p-value here. Okay, so I'm going to show you how you get this 0.0829 from your GC. Follow me, okay? Take out GC now. All right, take out GC now. You all know the drill. Stat. Calculate. Test. This time you should have correctly identified you are going to do a t-test. Option 2, t-test. Now, we are going to use stat here. Must be very clear. The mu naught here is you're going to test whether the top time is 15 or not 15. You enter 15. X bar was your sample mean. Your sample mean you found out to be 43 over 3, yes. 43 over 4, sorry, divide by 4. Alright, this was your sample mean. Sx is your unbiased estimate. Then you ask, you said variable. Then why you put in the variable? Of course, must put in, right? Just like x bar also variable, ma. Correct? X bar also variable, you must put in so that you can calculate the specific value of t, whether you reject the test or you don't reject. Just like this, you also put in, x bar is also variable, ma. But from your sample, you got some value. Follow? So you also put in your unbiased estimate, which is square root of 35.357. 35.357. N was small, it was 8. And you do a two-tailed test. Then you calculate. Then very happy you got this value. Same as the notes. And in fact, the GC will also help you calculate the specific t value. What is the t value? It's equivalent to your standardized z value. I don't intend to go through this. This one, again, not necessary, okay? This one, not necessary if GC can calculate p value. So equivalent. Okay, then I want to go through this calculation here. This one. I'm trying to explain this, okay? Can you look up? Look up, Think what I want to say. In your z-test, you have a z value to decide whether that z value falls in the rejection region or not. Correct? Typically, no need to copy. I'm just saying. Okay, I draw here, but you don't need to draw. For example for z-test. Correct? It's 0. Then you say, oh, my z value is here. I compare against my rejection region. If my rejection region is here, my z value, how I calculate my z value, it must be x bar minus mu over sigma over root n, right? Then you get some value, 1.6 or whatever. Correct? Example. So then you compare the z value with your rejection region, whether it falls in the rejection region or not, then you decide whether you reject or not. That's one way of decision making. Alright? Similarly, for your t-test, you have a t value. How you calculate this t value is exactly the same as how you calculate the z value. You just take x bar minus that mu naught, divide by, instead of sigma over root n, you put s over root n, you get this specific value, t value. Now, I know the GC can give us this. In fact, you look, the GC can give us this directly without this calculation. Here. See? To put this in context, where is this negative 2 point? It's here. It's here, negative 2.02 is here. You are going to compare against your rejection region. I'm not going to calculate the rejection region because there are some examples that we need to calculate the rejection region later on. But for now, you know this came from there. Follow? Okay? But for this problem, since the GC can give us p-value, we base our decision on p-value, compare p-value against your level of significance. If it's smaller, then you say it's a rare event. Remember? Correct? It's a rare enough event. Therefore, H0 is not true. Therefore, this mean cannot be 50. Follow? Correct? Decision making is always the same. You compare your p-value against your decision making threshold. Correct? You compare your p-value against your decision making threshold. You decide that therefore this is small enough, then H0 is rejected. So you conclude in context. So there is sufficient evidence to say that the average talk time is not correct, or 15 is not correct. Oh, sorry. Yeah, how you go down? Sorry, yeah, sorry. Here. Here. Now the question also explicitly asks, state any assumption made in testing then one suspicion. Even though we actually answered the question earlier, let's be a bit more explicit to answer this last part of the problem. State any assumption. What is the assumption? X must be normally distributed, and we don't say X. We be a bit more clever. Look, not very clever also must sound a bit clever. Sound clever to say that, oh, we assume that the talk time follows a normal distribution. So just say X. Okay? Okay? Go here. Don't just say X, okay? We must say what is X in the context of the problem. Okay, faster. I'm a bit desperate for time. We only have, after today, we only have 3 more lectures to go. I aim to complete with 3 more lectures. That is including stat 7 linear regression. It's a challenge, but never mind. We can do it. Okay, example 7.